Hello and welcome to Chemistry Form 3. We are talking about the mole and we'll go through a question on back titration. My name is Enoch Oyoka. 2.5 gram sample of calcium carbonate was added to 100 cubic centimeters of hydrochloric acid solution A. The resultant solution was transferred into a 250 ml volumetric flask, distilled water added to the mark and labeled solution B. 30 cubic centimeters of solution B was required to neutralize 25 cubic centimeters of 0.3 molar sodium hydroxide solution. Determine the concentration of hydrochloric acid solution A, given that the relative atomic mass of calcium is 40, that of carbon is 12, and oxygen 16. Before we even go to how we'll go through until we find the concentration of hydrochloric acid solution A, it is important to realize that the reaction between calcium carbonate and hydrochloric acid will be in such a way that one of the reagents is in excess, and this is definitely hydrochloric acid, so that after the reaction has taken place, whatever remains as unreacted hydrochloric acid will be diluted by adding more water to form a solution whose total volume is 250 ml, and then a portion of this solution, which is 30, will now neutralize 25 cubic centimeters of 0.3 molar sodium hydroxide. Now let's go to the questions and see how can we calculate the concentration of hydrochloric acid solution A. The first question reads, determine the number of moles of sodium hydroxide solution that were neutralized. As we know, the solution sodium hydroxide was 0.3 molar, which means in 1000 cubic centimeters of the solution, there were 0.3 moles. The volume of sodium hydroxide used was 25. How many moles would it contain? So 25 multiplied by 0.3 over 1000 gives us 0.0075 moles. Over to the next question. Calculate the number of moles of excess hydrochloric acid solution B used. This is simply how many moles of hydrochloric acid solution B reacted with sodium hydroxide. Therefore, we have to invoke the concept of mole ratio, which then means we must write the equation for the reaction. Sodium hydroxide will react with hydrochloric acid to form sodium chloride and water, and we can clearly see that the reacting mole ratio sodium hydroxide to hydrochloric acid is 1:1, which then means this way: the moles in 25 cubic centimeters of sodium hydroxide equals to the moles of hydrochloric acid in the 30 cubic centimeters. Therefore, the number of moles are the same, 0.0075 moles. To another question, determine the number of excess moles of hydrochloric acid solution A. I want us to recall that all the excess moles of solution A were made up to a total volume of 250 ml. Therefore, what we need to find here is the number of moles in this solution B that was prepared, the total volume. Already from the previous question, we've seen that 30 cubic centimeters contains 0.0075 moles. What about the whole amount that was prepared? 250. Therefore, 250 multiplied by 0.0075 all over 30, and that gives us 0.0625 moles as the total number of moles of hydrochloric acid that were in excess. How many moles of calcium carbonate were in the 2.5 grams added to solution A? Here, to find the number of moles, we must first calculate the molar mass of calcium carbonate, and this is where the relative atomic masses will come in handy, of which you first need to know the formula of calcium carbonate, CaCO3. Therefore, 1 atom of calcium, 40, 1 atom of carbon, 12, 3 atoms of oxygen, 16 times 3, and when you add up that, it gives you 100 grams. Now, Therefore, it means that 1 mole of calcium carbonate, a mass of 100 grams. What about 2.5? So 2.5 divided by 100 gives us 0.025 moles of calcium carbonate. Over to another question. How many moles of hydrochloric acid solution A reacted with calcium carbonate? This can also be found by first writing the equation for the reaction between calcium carbonate and hydrochloric acid. And you can see calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon 4 oxide, and water. And from the balancing of the equation, it is clear that 1 mole of calcium carbonate requires 2 moles of hydrochloric acid. So the number of moles of hydrochloric acid required will be twice as much as the number of moles of calcium carbonate. Therefore, we'll take 2 multiplied by the number of moles of calcium carbonate that were used. 0.025 will give us 0.05 moles. To another question. How many moles of hydrochloric acid were in 100 cubic centimeters solution A? Here we have already seen that we have gotten the number of moles of hydrochloric acid which reacted with calcium carbonate, and then we also found the number of moles of hydrochloric acid that were in excess. Therefore, what we shall do, we'll add up the excess moles plus those that reacted with calcium carbonate. Therefore, 0.0625 plus 0.05, which gives us 0.1125 moles. Now, finally, it is to determine the molarity of hydrochloric acid solution A. Now that we have found the number of moles of hydrochloric acid solution A, which were in the 100 cubic centimeters, molarity is all about finding the number of moles in 1000 cubic centimeters. So 1000 multiplied by 0.1125 divided by 100 gives us 1.125 moles in 1000 cubic centimeters. Therefore, the molarity of solution A is 1.125 molar, and that is it. Thank you for listening. Thank you for watching, and I would wish that you click the subscribe button. You can comment, you can like, you can share. Thank you until we meet again in another lesson.